What if we replaced the Moon with Jupiter? Let us start by defining exactly where we are putting this gas giant to ensure valid experimental conditions. We are assuming the center of mass of Jupiter is placed precisely at the current position of the center of mass of the Moon. Since the radius of Jupiter is roughly 71,000 kilometers and the average distance to the Moon is about 384,000 kilometers, the planet fits within the gap with plenty of room to spare. This seems spatially conservative, but gravitationally it is an absolute disaster. The first immediate consequence is a bureaucratic nightmare involving the International Astronomical Union. Because Jupiter is 318 times more massive than Earth, the Earth technically ceases to be a planet and instantly becomes a satellite. We are now a moon of Jupiter. This likely violates several treaties regarding planetary sovereignty, not to mention the complete disruption of global positioning system satellites, which would be flung out of orbit like pebbles from a slingshot. The short answer regarding the view is yes, it would be spectacular, but you will be unhappy. Jupiter would span about 40 degrees of the sky. To put that in perspective, imagine a dinner plate held at arm's length. Then imagine that dinner plate is 80 times wider and fills a quarter of the horizon. You would be able to see the turbulent cloud bands and the great red spot with the naked eye, assuming your eyes have not yet boiled in their sockets. Actually, it is even worse than just a visual intrusion. The gravity of the Moon creates tides that rise and fall by a few meters. Replacing that mass with Jupiter increases the tidal force by a factor of roughly 25,000. We are not talking about water tides anymore. We're talking about land tides. The solid ground beneath your feet would bulge upward by nearly a kilometer as the Earth rotates. This constant flexing of the planetary crust would generate friction, similar to bending a paperclip back and forth until it gets hot. Except here, the paperclip is the lithosphere of the Earth, and the heat is enough to turn the surface into a global ocean of magma. If you want a preview of your new life, look at Io, the innermost Galilean moon. It is the most volcanic object in the solar system, and it's significantly further away from Jupiter than we are in this scenario. Earth would essentially become a superheated, molten hellscape within days. The atmosphere would be stripped away or choked with volcanic ash, violating every air quality standard set by the Environmental Protection Agency. Good news, you won't even feel the tectonic liquefaction of the continents. Before the ground melts, you'll have to deal with the magnetic field. You are now deep inside the radiation belts of Jupiter. The energetic particles trapped there would bombard the Earth with such intensity that the ozone layer would be shredded instantly. The surface would be sterilized by a mixture of charged plasma and high-energy radiation. As you stand there, moments before the atmosphere ignites and the crust dissolves, you might notice strange flashes of blue light in your vision, even if you close your eyelids. That is not the sky. That is high-energy particles slamming into the fluid inside your eyeballs, creating shock waves of light faster than the speed of light in water. That is Cherenkov radiation. It's the last thing you'll ever see, but at least it will be a lovely shade of blue. Would you like me to calculate how long the Earth would survive before crossing the Roche limit and disintegrating into a ring system?